Okay, so in this lab, in this section, what we're going to do is, if you recall our conversation about association rule, one thing that is the foundational association rule is Ziffin distribution. If the data doesn't follow Ziffin distribution, then a priori algorithm is not appropriate. That implies that we'll have to massage the data, we'll have to put a bunch of products into categories so that it becomes Zipf distribution. If not, then the algorithm will not converge. That implies the cost of running the algorithm would be huge. It can lead to, in the worst scenario, 2 raised to the power n, where n is the number of items. So in our case, we looked, n was 169, so it could be 2 raised to the power 169 combinations that you have to go through. So in order to find out whether the data follows Zipf distribution or not, a quick way is to use Tableau, and it gives some beautiful visualization. So that's another good thing about Tableau. Now in this case, we'll connect to PostgreSQL Server. I was trying to do that in the class, and I was having some issues on the machine that I was working on. So in the server, I will type 147.126.64.66, and the database, of course, going to be INFS 494 lowercase, and the port going to be 8432, and the username going to be data miner, and the password going to be fall 2015. And do not click require SSL, just click OK. And this connects to our Postgres server at Loyola. Now here's the table that I'm interested in, to grocery underscore vertical, that I create out of the view as in our RLAB02. And this leads to 2 column. TID is the first column, and the reject regular expression underscore split to table is the other column. Now I can go to sheet, and I see, okay, reject split to table is nothing but item, so I can rename it, give it a right click, and here is rename, and I can rename to items, and I click OK. So now I got items, and I can take items over here, and this will give me about 169 items, and then I'll take number of records, and so now I got items and number of records corresponding to each item, and that is, number of records is nothing but the frequency. So now once I have it, what I can do is I can even shift this like this, and I can sort the data. If you go to number of items over here, you can sort the data. So if I do it like this, it will go other way around. If I do it like this, it will go with no sorting, and now it's in the descending sort. So the highest first, and the lowest in the bottom. Again, this is a way by which you can shift between row and column. So there's a way to do shift in row and column. Again, over here you can do similar kind of thing that we've already done. So this is nothing but sorting, and these bars are nothing but a depiction of the frequency for each item. So it's no surprise that whole milk is the most popular one. It's almost like 2,500 times being bought in different transactions. So that's the most popular, followed by other vegetables, and so on and so forth. Now we can substitute this bar graph by line. So if I do that, this becomes a line. And the question is, does it follow Ziffin distribution? Now this whole graph is very wide. So to see it in one picture, we had to fit the entire view in one picture. So once we do that, we do see there is an exponential decay. So from 2500, it falls down to less than 1000 within very few data points. And that implies that it may not be exactly Zipf distribution, but this data set does follow some characteristics of distribution, Zipf distribution. It does decay exponentially, it does decay very, very fast. And so we do not have to consider all this data which is sitting here after. We can literally exclude them after our first iteration of a priori algorithm, where we have some minimum frequency of say 10% or 20% or whatever. All these items will be thrown away, and a priori algorithm would be working only on this item which is left over here. So in Tableau, very quickly, once you have the data sorted out in vertical format, the way we did in Lab 2, You can use Tableau, hook it to the database, and you can run this visualization very quickly across billions of rows. So very scalable way of doing it, and a very neat way of doing it. And if you go to Windows and presentation mode, and you see this presentation of the entire data set, and it does follow the Zibin distribution. So that was about how to use Tableau, connect it to the database, and how to see whether your data set is a good candidate for association rule.